last noise? Share in the comments. Do you use this while falling asleep or while focused on the next day? The whole story is worth hearing. Wild speculation. We don't have all the answers, but we tell the as always, stay curious, stay calm. Now let's ask, why didn't we go extinct 10 million years ago? Now let us step back into the world that came long before us. Hello fellow sapiens, and welcome to Sleepless Homo. This is slow storytelling for tired humans, whether you're preparing to sleep, cooking, working, or just letting a calm voice keep you company. If you find value here, a like and subscribe helps more people discover long-form science told softly, knowledge to outlast noise. Share in the comments. Do you use this while falling asleep or while focused on tasks? Or maybe tell me where you're listening from. And if you happen to drift off mid-chapter, there are timestamps below so you can return the next day. The whole story is worth hearing. This is a channel for soft science, not wild speculation. We don't have all the answers, but we tell the evidence as always, stay curious, stay calm. Now let's ask, why didn't we go extinct 10 million years ago? Let us step back into the world that came long before us, when apes ruled in a way that feels almost impossible today. Did the world almost belong to them long before humans ever arrived? Between 20 million and 10 million years ago, during what scientists call the Miocene epoch, the Earth hosted a richness of ape life that dwarfs the fragile handful of species we see today. Fossils from Africa, Europe and Asia show us a planet alive with primates that filled every corner of the warm forests and wetlands. Some climbed through the canopy, some stalked the understory, and others tested new ways of moving and eating. In this age, the great ape family exploded in number and variety, not through one path, but through many simultaneous experiments in survival. The Miocene was not a single scene frozen in time. It stretched over 10 million years, a span so long that entire mountain ranges shifted, seas rose and fell, and forests expanded over continents before retreating again. At its start, around 20 million years ago, Africa was still a continent slightly isolated, holding forests dense with early primates who had only recently diverged from their monkey-like ancestors. In this lush beginning, species such as proconsul found a foothold. They were not quite like today's apes, but they were not monkeys either. Their bodies lacked tails, their arms and legs hinted at a different future, and they filled the branches with an agility suited for a forested earth. As the Miocene progressed, something extraordinary happened. Apes spread out of Africa into Eurasia, and with each new region they entered, they adapted in ways that left behind fossils that look more like characters in a branching evolutionary story than any single straight line. In the European record, Dryopithecus swung among the trees with a shoulder more mobile than those of earlier apes, hinting at movements that we still recognise in the brachiating swings of gibbons today. In Asia, Sivapithecus appeared with facial features that strangely echo modern orangutans, though separated by millions of years. In Africa itself, forms like Afropithecus thrived, each with their own specializations in jaw shape, tooth wear, or skeletal adaptations. What made this time so unusual was the sheer scale of ape diversity. By the middle of the Miocene, scientists estimate that as many as 100 distinct species of apes existed, spread across 3 continents. They were not copies of each other, but a kaleidoscope of primates exploring different ecological opportunities. Some remained small, weighing just a few kilograms, leaping quickly from branch to branch and eating softer fruits. Others grew heavier, perhaps over 50 kilograms, able to break open tougher plant material or claim larger feeding ranges. It was, in every sense, a planet of the apes. To imagine what such a world felt like requires letting go of the narrow lens of today's forests. Now, in the 21st century, apes are rare, often endangered, and confined to small, fragile habitats in Africa and Southeast Asia. But in the Miocene, forests were vast. The world was warmer than today, sea levels higher, and tropical and subtropical greenery stretched. This was an invitation. They diversified. This was an invitation. They diversified not because they had to cling on, but because the environment offered countless new niches. This is what evolutionary biologists unity outweighs constraint. Much as Darwin unity outweighs constraint. Much as Darwin later noticed among the finches of the Galapagos Islands, Small differences in beak or jaw or body size allowed species to occupy different feeding zones and survive side by side without driving each other out. Fossil evidence suggests that in the dense forests of Europe, Dryopithecus may have eaten fruits and softer leaves, while in more open woodlands of East Africa, meanwhile in Asia, forms like Civipithecus experimented with other diets, perhaps relying more heavily on certain seasonal fruits or even tough seeds. So a delicate foundation. Environments change, climate shifts. Forests can recede as quickly as they expand, leaving specialists vulnerable, teeth, jaws, and bones in scattered deposits. Each fossil is a reminder of a vanished form, an evolutionary experiment that did not last. The question that lingers, then, is why? If apes were once so widespread, what made their glory temporary? Scientists studying the Mayas, ice sheets reappeared at the poles, rainfall patterns shifted, and regions that had been blanketed in forest began to fragment into mixed woodlands and open areas. For species tied to the canopy, this spelled trouble. Some adapted, many did not. Still, during the window from 20 to 10 million years, in the distance perhaps a heavier form rustles through leaves, its jaws built for something tougher. This was not a forest story played out differently, but with similar richness. Fossils from sites in Kenya and Uganda tell us of proconsul, Afropithecus, path of ape diversification. Some had elongated faces and powerful jaws suited for crushing, while others carried skeletal hints of postures that would allow more upright movement. Again, the Indian subcontinent was home to Civipithecus, and in parts of China other lesser-known genera left their traces. Each continent in its own way hosted the experiments of evolution, producing a mosaic of apes that together formed a global dynasty. It as a precursor to humanity, as if all these species were rehearsals leading to us. But science resists such simplicity. Most of these apes were not our ancestors. They were cousins, distant branches that thrived in their own right. They remind us that evolution goal, but a process of variation and survival in the moment. If conditions had remained stable, perhaps many of them would still be here. The haunting reflection is that for every flourishing there is a fading, so rich then and so reduced now. What does that mean for the apes who still live among us? And more unsettling still, what does it mean for us? The Miocene reminds us that life on Earth is years ago. Apes filled the world, branches of a family tree that once spread in every direction. The Golden Age was real. It belonged to them. But nothing in evolution lasts forever everywhere. During this epoch, the collision of Africa with Eurasia closed the Great Tethys Sea and created land bridges that allowed primates to spread farther than they ever had before. What had once been separate evolutionary arenas slowly merged, letting Africa. The fact that we see ape fossils from Spain to India during this window is still the story of the Miocene as one of botanical change. Expansive forests of oak, maple, and other that feel unimaginable today. Picture Germany with lived in these settings not because they conquered the world by force, but because the world itself gave them opportunities. In that sense, their golden age was not built on dominance but on circumstance. It is also worth remembering that apes were not alone in this flourishing. Shorter trunks, primitive horses no larger than ponies, antelope relatives finding their footing in the open woodlands, and predators that hunted among the shadows. The Miocene forests were not silent laboratories, but living, noisy ecosystems where every branch held a contest between survival and failure. That apes found so many ways to coexist with these shifts, and yet, the very success of Miocene apes makes the present feel uncanny. Out of nearly 100 species that filled Earth's warm forests between 20 and 10 million years ago, only a handful of great ape lineages remain today, and all of them are vulnerable. The contrast raises a sobering question. Was their golden age an accident of climate that could never last? Inevitability, but fragility. The diversity of apes then reminds us that Earth can host worlds entirely different from the one we know now, full of forms that seem sediment. Story could have continued in countless directions. We live in only one of those possible outcomes, and that realization is as humbling as what kind of world allows apes to flourish by the dozens? To answer this, we need to walk into the Earth of 20 to 15 million years ago, on the continents, and when forests seemed to stretch without limit. It was the height of what geologists call the Miocene climatic optimum, a period when the Earth was several degrees warmer than it is today, and when the great forests expanded northward and southward to embrace much larger swathes of the continents. In this warmth, apes found a cradle. Not just one kind, not just a few, but dozens upon dozens of different forms, each testing its own survival strategy in an environment that seemed almost endlessly generous. If you could step into those forests, you would be struck by their density and by their scale. Vast stands of evergreen trees mixed with broad-leaved deciduous giants, stretching high into a humid sky. Producing a complex vertical world, temperate or even arid, across the canopy. Germany, France, and even parts of Britain were cloaked in woodlands, more reminiscent of equatorial Africa. Asia too, from India to China, held sprawling forests that reached across entire regions. And in Africa, still the heartland of primate evolution, woodland supported a wide range of... It is within this world of seemingly endless forests that apes radiated into extraordinary diversity. Biologists call this process adaptive radiation, the rapid branching of a lineage into many forms when ecological opportunity presents itself. In the oceans, we see it in the Cambrian explosion of marine invertebrates. On Earth, we see it in apes. The reason is simple. A warm, wet, forested Earth created niches in abundance. Fruits ripened at different times, leaves presented varying levels of toughness, insects buzzed in layers of the... For a lineage that lived in Africa during the early Miocene, fossils found in chimpanzees were beginning to carve out a unique way of living in forests that rewarded versatility. As the forest continued to expand during the warmest stretches, in Europe the genus Dryopithecus emerged. Leaving behind fossils. Afropithecus evolved with a more projecting... Each form was not a step along a single road, but a separate experiment in how to live in an Earth that offered many ways to make a living. The richness of Miocene ape life was not limited to differences in diet or locomotion. Body size varied widely, from kilograms to larger species that reached the mass of a modern chimpanzee or more. This variation allowed species to occupy different vertical zones in the forest, chasing insects or plucking fruits that grew at the tips of fine branches. Larger apes could dominate lower canopies, breaking sturdier branches and consuming tougher foods. Layered habitat, and apes took advantage of every of 20 to 15 million years ago is how widespread apes became. Their fossils are not confined to one continent or one corner of the tropics. From Kenya and Uganda to Spain and France to sites in Asia, apes appear again and again in sediments of this age. They were not marginal players, but dominant sediments of this age. They were not marginal players, but dominant mammals of their environments. They lived alongside early elephants, and yet they held their ground, finding ways to... It is worth pausing here to think about the scale of apes not as the mix we know today, but as broad subtropical forests that stretched for hundreds of years unmatched at any other time in their history. This golden world of endless forests was delicate. The very conditions that made apes so diverse, warmth, moisture, and forest spread, the question that echoes across time is whether such richness was sustainable or whether to contract. When we look at the Miocene of 20 to 15 million years ago, we see a world of forests that expanded into regions far beyond the tropics and a diversity of ecological niches that invited apes to flourish. They did not dominate the earth through conquest, but through adaptation to a world that seemed, for a time, limitless. The haunting reflection is that such lushness has never returned on the same scale. The earth of today cannot host that same variety of apes, no matter how much we might wish it. Their golden forests are gone, leaving us only fragments in the fossil record and the reminder that abundance is never guaranteed. Why did apes evolve into so many shapes and lifestyles? Between 15 and 12 million years ago, the Earth staged one of the richest evolutionary spectacles in primate history. This was not a world of a single kind of ape, nor even a handful, but a teeming carnival of forms. This period was its parade, noisy, varied, and filled with experiments in how to live, feed, Europe and Asia. Some leapt through branches light as dancers, Europe and Asia. Some leapt through branches light as dancers, others moved deliberately with the weight of browsers, and some even adapted to swampy environments that most mammals would have avoided. To understand why, we need to look at how ecosystems shape zebras, antelope, giraffes, and gazelles can all graze in the same region, because each eats different plants or feeds at different heights. The same principle seems to have operated in Miocene forests. One ape lineage specialized in fruiting trees, another in harder seeds, another in leaves from the understory, and still another in swamp vegetation. This partitioning reduced but with it, variety flourished. In Hungary, Dryopithecus remains show evidence of a fruit-heavy diet, perfectly suited to Europe's warm forests. In Anatolia, Gryptopithecus left behind jaws with thick enamel, suggesting it could exploit harder foods. In Kenya, robust enough for fibrous plants, while still agile enough to climb. In each case, subtle differences in anatomy correspond to different ecological roles. Who even tested the waters of swamps and wetlands? The Middle Miocene brought a maturity to the ape lineage that earlier periods had only hinted at. In Africa, Proconsul and its kin had laid the foundation for ape-like bodies without tails and with strong grasping limbs. But by 15 million years ago, a broader range of forms had emerged. In East Africa, fossils of Kenyapithecus suggest a sturdier, more terrestrial animal, one that did not spend all of its life clinging to branches. The teeth of Kenyapithecus hint at a diet that included tougher foods than those of its predecessors. This was a primate beginning to test life on the ground. Not abandoned, it filled a different role. Its long arms and flexible shoulders suggest match perfectly to the lush forest that then covered parts of Spain, France, and Central Europe. Dryopithecus demonstrates another branch of the carnival. A specialist in soft seasonal foods that required agility and reach. Side by side with Kenyapithecus, it illustrates how the same family could generate very different solutions in different regions. Asia, too, added its own performers to the parade. Sivapithecus, whose fossils are found in India and Pakistan, bore a striking resemblance in its face to modern orangutan terrestrial, combining fruit-eating with other dietary options. It shows us how Asia's forests hosted their own experiments, parallel to but distinct from those in Europe and Africa. The oddities of this Oreopithecus had unusual limb proportions, with features suggesting it may have been capable of walking upright at least occasionally. Its teeth, however, show adaptations for consuming foods found in swampy habitats, likely includes that when the Miocene offered wetlands and isolated islands of habitat, some apes accepted the challenge. The Middle Miocene carnivore was not limited to diet and locomotion. Social behaviour, though harder to detect in fossils, likely varied as well. Have moved in larger troops, darting quickly and exploiting abundant foods. Larger bodies. These differences further diversified how species. It is important to resist seeing it as leading inevitably to us. None of these apes were on a straight path to becoming human. They were successful in their own right, filling environments that no longer exist today. Evolution does not plan ahead. It responds to opportunities. To 12 million years ago, the opportunity of ecological richness, geographic spread, and evolutionary flexibility was warmer, wetter, and greener. Forests stretched across continents. Apes, with their grasping limbs, varied diets, and social complexity, were particularly well suited to diversify within them. And so they did, leaving behind a fossil record that looks less like a family tree and more like a tangle of vines. The Middle Miocene carnivorous forests, the word ape could mean a suspensory browser or something in between scale. Today we see only the shadows of that diversity, but in their time they filled the world with variety. But when many coexist, each filled the forests of 15 to 12 million years ago with a richness we can scarcely imagine. To understand the depth of this carnival, it helps to widen the lens beyond the well-known names and pay attention to the suspensory movement of Dryopithecus. Instead of specialising in aerial acrobatics, Nacrolopithecus seems to have adopted a more measured, deliberate strategy. Moving subtle differences in locomotion could carve out an ecological role in the crowded Miocene forest. Other discoveries highlight how apes spread into unexpected corners. In parts of Asia, Pleobates, sometimes called lyre, after the remarkable fossil discovered in Spain, but whether you're preparing to sleep, cooking, working, or just letting a calm voice keep you company,